My research is using high resolution image and physics-based hydrologic model to see how disturbance fire affect runoff and erosion. In last year, there was a prescribed fire in Johnson in Reynolds Creek. It's a long-term agricultural research watershed by USDA ARS, and because the benefit to study a prescribed fire is we know the fire will happen, so we can get the pre-fire data and the post-fire data to compare how the fire affect vegetation cover and hydrology. We flew a drone for this transect, the south-facing hill slope, and we choose this hill slope because we have some ground observation. We have a weather precipitation station. We have some other soil scientists measure soil hydrologic conductivity and other measurements. So we choose this transect. So this is the pre-fire and post-fire US, the drone image. To quantify the vegetation cover before and post-fire, we use a deep learning model, segments anything to segment the objects in vegetations like sagebrush in the image. Then we use extreme gradient boosting machine learning classification to classify this polygon after segments anything model. This is some just a closer look of the vegetation classification before and post fire. We can see shrub cover decrease a lot after fire. It's hard to see in this image, but based on our classification results, the ground litter also decreased a lot. Then we use this. So we did two scenarios in our hydrologic modeling. The first scenario is use the pre-fire vegetation cover with the precipitation data from the weather station. The second scenario, we changed the pre-fire vegetation cover using the post-fire vegetation cover as the input. So in these two figures, those dots are the storm events, and the blue dots are the model scenario using the pre-fire vegetation cover, and the orange dots are the post-fire scenario using the post-fire vegetation cover. And yeah, it's not surprised the post-fire we can see a greater peak runoff rate and a greater erosion. So our next step, we are going to also include the National Land Cover Datasets rangeland analysis platform, the 30-meter resolution data to estimate the hill slope vegetation covers. So to compare how the different resolution affect vegetation cover estimation and how this uncertainty will affect hydrologic modeling. Because in our in one of our paper just published last month, we found that the satellite image really underestimate has a very large uncertainty to estimate vegetation cover in this sagebrush dominant ecosystem, and we would like to know how the uncertainty of satellites will affect hydrologic modeling.